Thanks, Angus, and thanks for the warm welcome. It's a real privilege to be here today. There's a lot of familiar faces. Yeah, so I'm Matt Callanan, and I'm a software engineer. I work for Expedia.
And I'm Alexandra Spillane. I have a confession to make. I'm not actually a dev. I'm in ops, so just don't hurt me, okay? Just stay seated.
Is there any other sysadmins here today?
Yeah.
One. Welcome. So our story is about our journey at Wotif. Wotif was acquired by Expedia last year. So we're based out here, still in the Wotif headquarters office out at Milton. We now do more centralized work for worldwide teams around the world for Expedia, helping adopt DevOps and continuous delivery, working with Docker and Amazon services and traffic management. But yeah, the story is about Wotif, and we went through a transformation of our release processes in the years 2013 to 2014, where we reduced our average release cycle time, which was measured in weeks and sometimes even months. We got that down to hours and sometimes even minutes. And this was no mean feat for an IT department, 170 people, we had 12 development teams, we had a single very over-constrained operations team. And so we were also constrained at the time to the data centers. There was no magical, blue-green deploys to the cloud for us at that time. I just want to cover off the term DevOps for those that might be new to it, or at least have a working definition. There's many definitions. It was originally called Agile Infrastructure, there briefly, and it's essentially about taking those Agile ideals of collaboration and fast feedback, taking them out to include the last mile, so to include operations, which often suffers from a throw-it-over-the-wall type of mentality. And it doesn't just include ops, it includes business and testing and security, but the term biz, dev, test, sec, ops doesn't really roll off the tongue, so we've got DevOps. And it's also about collaborating between all those teams, but also about the idea of fast feedback and tooling. How can we get the fastest feedback possible to the people that need it? If you could sum it up in one word, that word would be empathy, understanding how the other side feels and walking a mile in their shoe. And with DevOps, we believe that people want to do the right thing. Like no one sets out to maliciously sabotage the company when they wake up every morning. But ultimately, we end up doing the easiest thing, whatever's the most practical, pragmatic thing to get the job done as fast as possible. So you could say like the DevOps dilemma is how do we make it easy to do the right thing when our dev and ops teams aren't even talking to each other? And that's what we discovered at Wotif. Like we did a lot of stuff with continuous delivery and changing the way we did software. The biggest thing that stood out to us was this idea of making it easy to do the right thing. So today we're going to talk about what is that right thing? How do we go about defining it? And then how did we go about making it easy? And then some of the lessons we learned along the way, and have some time for questions at the end.
Cool, so let's get started. First, we wanted to talk to you a little bit about how you go about defining the right thing. Oh yeah, that works. The DevOps movement, it's all about working together, collaborating, working together to automate deployments, automate testing, reduce batch size. But how do you start bringing those great DevOpsy things into your organization when it seems like there's a chasm between your development teams and your ops team? How do you decide what's right, and how do you even start talking about it? So I'll take you through a little bit of the context, a few of the problems that we're encountering at Wotif. In 2012, we were in the middle of what you might call a downward spiral of problems with our release process. We had quite a siloed IT team. Our silos were being reinforced every day through different cultural and technical issues. We had quite low morale in many teams, lots of passive aggression across teams and finger pointing. The ops team was quite overloaded, and dev teams were getting really frustrated because they just didn't feel like they could get code out to production fast enough. So obviously no one was happy about the situation, but there was no real avenue for us to move forward. There was no way for us to come together and talk about it in a non-confrontational way and find a way out. So our release process had lots of overhead, lots of bureaucracy, lots of manual deployments to every environment, manual testing on release day. We had really large batch sizes because these problems of the release process meant that people would stuff more and more into every release to kind of get more bang for their buck. We had a lack of visibility. Ops didn't know what was going into each release. They would just, perform the steps and not really have any clue what was going on. Dev teams had difficulty figuring out what metrics were available to look at in production, what monitoring was happening. Our dev teams also had trouble telling what other dev teams were doing, what they were releasing, or where they were at in their pipeline. On top of all this, we had a scheduling problem. We had this massive calendar of doom, and you had to schedule all of your releases to production in it, but it meant because it was so full, you would have to schedule weeks in advance. But once you got your slot, you'd probably be bumped out in 2 weeks anyway, because a higher priority release would come along and kick you out. So once you got to the top of the queue, you had to face a kind of superstitious gatekeeping process. For instance, most releases had to undergo performance testing, even if it wasn't really necessary for the release, and that would hold up every other release because there's only a single performance test environment. So this all meant that our applications were stagnating. We could barely keep up with business functionality, let alone address technical debt or keep up with what the industry best practices were. So a lot of you will be familiar with the continuous delivery book, I hope, and if you're not, you should go read it. The manual deployment anti-pattern from that book reads like someone came to Wotif and wrote down what we were doing. So we had endless documentation, manual deployments and testing. We had deployments that went wrong on release day. We had special snowflake environments that were all, slightly different from one another in unpredictable ways. And releases would take hours and tie up maybe half a dozen people. So not great. This is a bit of a diagram, an illustration of the pipeline. Releases would be dev complete and ready for release, and then they would queue up for weeks and just sort of sit there stagnating. By the time they made it to the top of the queue, they'd kind of then have to fight their way through our staging, deployment, and then performance test, and then this kind of random gatekeeping process before they finally made it out to production and hopefully didn't get rolled back. So in the midst of all this, some bright spark heard the term microservices. And yeah, they thought that that was a great idea. And you know what, in all fairness, it is a great idea. It was a great idea for us. We had a set of kind of sub-monoliths, and they were causing even more pain for us. So we thought, oh, well, all right, well, let's look at moving to microservices. But everything was being manually deployed and tested. So as you can imagine, this made things a heck of a lot worse. So as part of that microservice re-architecture, we moved from a heavy glass-first JWE container across to a lighter weight framework called DropWizard. And we got lots of speed and simplicity out of that. But we'd built a lot of operational consistency around Glassfish. We kind of had these scripts, and ops kind of sort of knew what to expect with the scripts. When DropWizard apps started coming into the pipeline, they were all doing things slightly differently. So different config file locations, different init scripts, different log file formats, log file locations. And this really slowed us down, slowed ops down. Because you get an SMS at 2 a.m. and you log in to figure out what's wrong with an application. Like, well, actually, now I have to go consult the documentation because I don't know how this application worked. Whereas, last year, if it had been Glassfish, I would have just automatically, oh, I know where the logs are and I know what to do to restart it or whatever. So that's the context. That's a little bit of what was going wrong at Wotif in 2012. So now we can start looking at how we kind of started to climb out of this chasm, how we started to move from wrong to right. So in 2013, we had a reorg in the IT department. A continuous delivery team was set up. There were 4 of us, Matt, myself, another senior developer, and a process improvement BA. And the goal of our team, the overarching goal, our vision, if you like, was to reduce cycle time from weeks and sometimes months down to less than a day. And at the start, we were like, well, this will never happen, but we'll see how we go. And the first thing that we kind of noticed was, well, there's a tension between flexibility and predictability. We really love innovation, and we want our developers to be able to innovate. Yeah, I know I'm a sysadmin, but even I want our developers to be able to innovate. But we also need consistency and predictability in order to be able to support things in production and to handle it when things go wrong. So the question became, how do we promote a culture of responsibility and freedom while still providing predictability and supportability? So it's kind of a dirty word, but it's not really. Standardization. We decided that we would look at the surface of our applications, the surface that operations interact with. That would be deployment mechanisms and application packaging. We decided to standardize on that and then let the developers go nuts inside, do whatever they want inside, as long as on the outside, it always looked the same to ops. So we wanted to empower developers, to adopt new technologies and innovate without ops necessarily having to care about that at release time. So it's kind of difficult to do. Like, as I mentioned at the start, we weren't in a great place communications-wise. We weren't having productive conversations across teams. So we had to get people's opinions about stuff, but without them being defensive or feeling that they had to argue about it or fight about it. So really we just started by having one-on-one discussions. I would go to my colleagues in ops and say, okay guys, what do you reckon? If we could do anything, what would we do? How would we fix this as ops if we had like all of the money and we could just tell the devs to do whatever we wanted and they would just do it? And we started to write that stuff down. And then people like Matt and the other dev in our team, Chris, they would go to the dev teams and pretty much pose exactly the same questions, but kind of incentivize it by saying, well, if you give us this feedback, then we'll help you get your applications out to production faster. And so we just started to gather ideas and we put them on a Confluence page. We called it Lightweight Application Deployment Standards. It was just full of stuff. But as people got more used to providing their input and not having to argue about it and understanding that, yeah, it doesn't matter how far out your idea is, we're going to collect it and we're going to think about it anyway. You won't just be shut down, because I guess that was one of the problems, is that you just get shut down before. So we started to collect these ideas. Once people got used to that idea of not having to argue about it, then we kind of moved into a meeting phase and started having collaborative meetings with people across Dev and Ops together, as well as management, architecture, QA, and obviously BAs as well. Architects, did I mention that? Yes, very important. So we had this input and we really tried to incentivize it. And if you could think of a thing, it was in the document. Log file formats, log file locations, config files, init scripts, application endpoints, firewall configuration, JVM tuning, anything you can imagine, it was in the document. Obviously you can't address all of that at once, but this is just an example. We standardized log file formats. This is just the way you do it in Java, apparently, they tell me, these devs. And it seems like such a trivial thing, like who cares? But it actually matters. Like when it's 2 AM and you've got to look at like 50 different log files to figure out what's going on, it actually really helps if they're all in the same format. So, and as I mentioned, we collected a lot of stuff, and you can't address everything. Like it's just not ever going to work. So we basically picked the low-hanging fruit. We decided which things were going to be relatively easy to implement using shared libraries or kind of minor changes to packaging. And we picked that as our version 1, and then everything else we stuck in a future considerations section. And we allow people, because it's just Confluence, to just comment on pages if they had ideas. Whenever they wanted to, they could just add to the page. So it kind of turned into a bit of a life cycle. We'd come up with new ideas for the standards. We'd say, is this going to work? Is this doable given the kind of current environment that we're working in? Okay, yeah, it might be doable. Let's trial it. Let's do reference implementations. Let's pick a guinea pig application to try out these ideas on. Is it working? Yes, it's working. Okay, we'll agree that this is the little set of things that we want to standardize at this point in time, and we'll move forward and try and implement it across all of our applications. And then back around for the next lot of things that we want to address. And always the thing that we're addressing is the thing that's hurting us most. It's the bottleneck or the thing that's wasting time. You don't pick, it's like premature optimization, I guess. You pick the thing that actually matters right now, not the thing that might matter 3 months from now. So our standards document, it kind of became a platform, became like a demilitarized zone where we could open lines of communication between teams. At the time of the acquisition, our teams were still separate. We never integrated our ops and development teams. But we got them talking, like Matt and I are actually standing here and we're not like punching each other. So that's really good, and it was a really great thing to watch.
Yeah, and it represented a lot of hard work to get that far, start climbing out of that chasm, to start actually agreeing on the right thing. It represented a big cultural shift in the way that we were working together. But having a Confluence page that developers are going to have to read through and ops are going to have to understand intimately is not actually going to speed up releases, which was what we were trying to do. Now developers would have to be intimately familiar with it every time they wanted to release, and every time we updated those standards to new versions, they'd have to refamiliarize themselves with them. And with the business breathing down your neck to get releases out the door yesterday, the last thing they want you doing is reading Confluence pages. So we need to find a way to make it easy to adopt and to incentivize that adoption process. So we turned to automated testing. We built a compliance test suite using Python with the Fabric SSH library. And this test suite would essentially act like a very finicky sysadmin. It would log onto a box after the app had been deployed to it and started, and it would run a whole bunch of Linux utilities against that application, verifying whether it looked like we said it should in the standards. When we were coming up with the standards, we said for ideas that people had, we would immediately follow up with the question, how are we going to test it? You want to make sure that there's a JMX port available on base port +7 for every app. How are we going to test it? You know, using something like JPS or Netstat or something like that. So we put together a big test suite, and this was a really great way of bringing the operational feedback into development. So when a developer would make a commit to their code base, it would go and deploy that application to their test environment and would run this compliance test suite as part of that. So now developers were getting that operational feedback that they weren't getting until much later in the stage, so they could actually address that in their application while they were developing on it. And it was a great way that we could use test-driven operational compatibility. So if you were creating a new microservice, maybe splitting out some code from one of the monoliths, or maybe you're bumping up to a new version of the standards and there were some new test cases that needed to run, you could just commit your changes, and the compliance test suite, when it ran, all the failed test cases would basically give you a shopping list of things that you need to go and address in your code. And you could do all of that without even talking to ops, without even going and saying, what do we need to do? What are the changes that we need to make? And you didn't have to go and read the entire Confluence page. So you could test drive, red, green, repeat. We made the test suite backwards compatible as well. So we wanted to, we didn't want to penalize teams for adopting earlier versions of the standards. So if the standards were up to version 2.3 and you had made your app compatible back when it was 1.0, that was the right thing back at that time. That's what we all agreed. That was the cutting edge. So we didn't want to penalize you. We wanted to still give you a way to be able to deploy your application and meet the agreed standards of that point in time. So we made our test cases backwards compatible by being able to say to each of our test cases which version it applied to. And this was a great way just to make it really easy to adopt all those different versions of the standards. This is some of the Linux utilities that Fabric would execute on the box. We were a Red Hat shop, so commands like RPM and yum and et cetera, et cetera. This is an output from the test suite as it's running. You can see it's skipping some of the versions that don't apply to that target version of the standards there. So that made it easy to adopt the standards without having to read the entirety of the specification. If you did have any questions, you could always go back to the standards and refer to them and ask questions from there. We also built a reference implementation, so Hello World service. It was deployed to production and all environments. It had no business logic, and it didn't receive any production traffic. So its sole purpose was to be a reference implementation for those standards. So you could use it as a base, that you could copy the code to create a new microservice, and you knew it was going to be compliant with the latest version of the standards. And every time that we changed our automation, so the deployments or the scripting for the deployments or the test suite themselves for the compliance, we would run the automated deployment for the pipeline for the Hello World service. So we knew if that broke, there was a problem with our automation before it affected all of our other applications. Rolling upgrades. So this was the term that we gave to when we update a suite, a cluster of servers for an application, we would roll through the different nodes in and out of the pool behind the load balancer. And automating this task was something that a lot of people thought was impossible, because we were doing all this stuff manually, the deployments and the testing. Like as a sysadmin, it's my job to protect production, so I have to do this manually. It'd be negligent to trust it to automation. And same as a tester, it's my job to hold back bugs from production. I have to manually inspect it. It would be negligent to trust it to automation. And developers would just, commit their code, dust their hands, and throw it over the wall to testers. So we took a step back from our release processes. Every single release had a release notes page on Confluence. Like the box there on the left is kind of the list of instructions that were copied and pasted from release notes to release notes, and errors would creep in, and there'd be a lot of applications that would just get thrown in because releases took so long. You had to add more and more bang for your buck to it. So we took a step back and said, okay, there's 4 main phases in each of our release notes. We can look at automating each of these in turn, and we started to do that, again, using Fabric with Python. We initially built it in an interactive mode, so when we gave it to sysadmins, it would prompt them, and it would say, about to run this command, and they'd say, yep, and it'll show them the output and pause before the next step, and they could see the output and compare it to what they are accustomed to seeing, and say, yep, I agree, that's good, I'm ready to go to the next step. So this was a crucial way of being able to introduce that automation, rather than just sort of giving them a whole bunch of scripts and saying, trust us, it works. But they could slowly build that trust up over a few months and then run it in interactive equals false mode. And for testing, we mandated as part of our compliance, as part of our standards, that each application had to ship with its own smoke test, which would test the application on localhost, on the box. And if that smoke test didn't exist, then we would fail the deploy, fail the compliance test, and you would reject the release. And similarly, if that smoke test failed when you ran it, it would fail the release. So this was a fail early type approach that we made sure that we had a way of getting automated testing into our releases. And we said to our teams, the minimum that you want to put in your smoke test script is the minimum manual testing that you would do in production. And this was one way that we could start introducing that. So with rolling upgrade for releases, we reduced the amount of time that it took to do a release from hours down to minutes, and reduced it by about 85%. So that was a really good cost saving. But even with the faster releases, we still had the calendar of doom. We still had all of these release prioritization issues. We still had all the gatekeeping issues. So it would still take weeks or months to get to the point to run a very, very fast release. So we took a step back and we did a bit of a review of all of our processes. We got select individuals from all areas of IT. We came away, we did a workshop, and we sat down and we said, okay, what are all the problems that we're experiencing? And it was kind of depressing. We came away with a big cause-effect chart, a mind map that would take hours to scroll through it. And there were a lot of self-reinforcing, negative, vicious loops in there. For example, releases take so long. Releases just take a long time. That's one problem. Okay, what's one cause for that? Well, we have to do this 48-hour load run. Well, why is that? Well, one reason is that there's just so much stuff. We don't trust the contents of releases. Well, why is that? Because there's so much stuff in there. Well, why is that? Why is there so much stuff in releases? Well, because releases take so long. We have to pile more and more. So there's this self-reinforcing loop. And it's really, really tricky to try and find a way out of that. At the same time, we're grappling with another thorny issue. So we're building all these microservices, and that's great. But how do we make sure that all of the versions of all the changes that we've made, that we've deployed in our test environment and tested together, how do we make sure that we deploy those downstream to our staging and production environments? That the things we've tested together are the things that run together. And I was posing this question to some of the guys at the workshop for the YOW workshop that Netflix held a couple of years ago here in Brisbane. And Adrian Cockcroft overheard and said, just make all your changes backwards compatible. Just make sure that all your teams are autonomous and all of your releases are independent. You want to optimize for speed in that process. And this one piece of advice really revolutionized the way that we thought about our releases. One morning we had Danny Williams, who's our boss still to this day. He's a production delivery support manager back then at Wotif. He comes in one morning to stand up and he's saying, slipway, slipway, slipway. And we're looking at him like, what are you talking about? It's the simple, lightweight, independent pathway. And we're like, ooh.
Ah.
And he said, this is going to be a culmination of all the things that we've been learning about continuous delivery and DevOps. It's going to be an opinionated, alternative path to production. We're still going to support the old way, but we're going to create a new pathway. And it's going to be based on these simple rules based on our new microservices. So the simple rules involve this I, independent, which is based on this idea that we have making all changes backwards compatible. So you couldn't, for a slipway release, you could only release one application. So there was no more cobbling together a whole bunch of different applications. You could only release one, and that forced you to make a backwards compatible change to support all the other existing clients of that microservice. Also, you couldn't have any other database or OS or networking firewall rule changes as part of that release. So we wanted to make it very opinionated and very streamlined, exactly what you could do in a release. Remove a lot of the unpredictability. We said there's not going to be any manual testing. You're not going to be able to pause for manual testing. You have to use the smoke testing and other parts of the automated test framework that we provided. And to solve the calendar of doom, we said you can't book a specific time in the calendar. If you want to get specific functionality out for a particular point in time, maybe for the 1st of July for taxation reasons or something, then you make that change ahead of time in your code base behind a feature switch, and you release it ahead of time with enough time to meet your deadline, and then right at that point where you need it, we'll flick the feature switch across. And basically the slipway queue was a first in, first out type queue, and we said it will be serviced within 24 hours. This really helped to remove a lot of the emotion that was pent up in our releases, because you can imagine it takes weeks and months, and it's very unpredictable exactly when you're going to release. You can imagine a lot of the fighting that can go on, saying my release is more important. I have to have this slot in the calendar. We just totally removed all of that emotion and angst that was built up in those releases. And we also said that you have to comply with the latest version of the standards. So we were creating new versions of the standards as we went along. We were adopting more and more things that we all agreed was the right thing to do, and to sort of incentivize adoption of what we agreed was the current right thing. We said, okay, well, the price you pay for having fast releases, for having more predictable, streamlined releases to production, the price you pay is complying with what we all agree is that right thing. So this is a Confluence page where we kept a list of our simple rules for Slipway, and we went around to all teams and gave them a consistent message and rolled it out and said, okay, this is how it's going to work, and this is what we're going to do. And teams really adopted it quite quickly, and within a few months, most teams already had at least one app on Slipway, if not more. So this diagram that we saw before, where it took weeks, sometimes months, to get that priority up to the top there. On the left, it also took days to get a simple change through development and testing, because we're doing a lot of manual activity and siloed behavior between dev and test. And then on the right-hand side, it would take days to get through that and the unpredictable prioritization and gatekeeping. With Slipway, we'd built a lot of maturity already with continuous delivery in our dev and our testing section on the left, so that was a lot quicker through there. And then the simple rules in the middle meant that it was a lot faster to get through and get into that queue. And then we managed to reduce the amount of time to get through staging and production down to hours. We made load testing optional. So we put the onus back on teams, and we said, well, you're the best. You're the guys that know the most about this change, and you know that you know how much risk is built up in this release. Because batch sizes were a lot smaller, inherently releases themselves were less risky. So putting the onus back on teams, most of them opted out of load testing and adopted more of a roll forward type mentality. We said you can still do load testing if you want, but most teams, because they were able to reduce their batch size a lot smaller, there was a lot less chance of things going wrong, and if something did go wrong, they're much more likely to know exactly what's gone on in the last couple of days of development. So they could either fix it fast and roll forward, or rolling back was also less risky because there was a lot less change to roll back. This is another view of Confluence where we use the Kanban view, and we just showed each of these bubbles is a release notes page. So we layered Slipway automation on top of our existing processes, which were using Confluence, and that made it really easy for teams to adopt. We automated the generation of these release notes pages. Each of the verticals is a different part of the queue, if you like, a different stage in the life cycle of getting a release out, and which team was responsible for it, etc. We also added some charts and graphs around, and it really helped to kind of gamify the adoption process. How quickly are we adopting Slipway? How many apps are on Slipway, etc., etc. So that was really helping to visualize exactly what was going on. Teams could see who was releasing what at where and where it was in the pipeway. This is a simple chat room. Events during Slipway, during the automation, would get published. to a chat room so everyone could see what was going on in environments. This was information that was locked up in sysadmin's terminals in the past. And we also saved a copy of the terminal for each release as just like a transcript of it, and attached it to the Confluence release notes page. So just using the Linux script command, captured all of that. So you could go back in history and see, okay, for this application 2 weeks ago, this is what happened, and why am I seeing something different this week? And just again, increasing the visibility that was around releasing. We also added charts and graphs. So this is just a simple cycle time chart that was added to each release notes page. So that was really putting cycle time as like a first-class concept in people's heads as well, and helping to encourage that as a primary concept. So the results. We managed to reduce the number of hours spent releasing on average down by 95%. This had the effect of essentially freeing up 3 full-time employees. Cycle time, so time to market reduction was down by 86%. This is in the year 2014. And on average, we increased the number of releases by almost 3 times as many releases. You'll see gripway mentioned on some of these slides. So after we adopted slipway, we gave our old process the affectionate nickname gripway because it was like full of friction, which was a great way to distinguish between the two. And what you can't see in these charts is like the morale, the influence it had on morale. So now teams were actually proud of releases, and they're excited about the opportunity to get their functionality out into the hands of customers, and they could actually have a sense of hope about the future for their code, and not be languishing in, oh, we never know when we're going to get this released, and it takes so long to get stuff out, and oh, there's so many bugs because we didn't know what we were doing 3 months ago. And, all those things added up to having a much greater impact on morale. So comparing gripway and slipway, our cycle time target was less than a day for our average release cycle time, the time between when an app was tested and ready for release and when it was actually in production. We almost made it to less than a day, just over a day, and that represented 7 times faster average release cycle time. If you multiply that out to include dev and testing, it would be well over 10 times, because we'd also increased the productivity that we had in that just because of lower batch size. Something we couldn't show last year at DevOps Days conference. This is something that developed late last year in December, about this time last year. It's this little blip over here on the right. I'm wondering if anyone could tell me the difference between continuous delivery and continuous deployment. Does anyone want to have a go?
Delivery is about product, deployment is about code.
That's one definition. Anyone else ever want to have a crack?
I would look at it as the difference between the ability to push out to production versus when you push out to production. I mean, one should ideally be a technical decision versus a business decision for the product.
I think he's got it. Yeah. So when do you push it out? Yeah. That's so continuous deployment was actually defined before continuous delivery by Timothy Fitz, I think, from IMVU. And it's with continuous delivery, you've got checkpoints where you say, is this product ready to go? So the business has a say in, yes, we want these features to go out, we're ready for it. So you guys go and do your work, and we'll decide when we're ready to move on. With continuous deployment, you build up so much maturity in your continuous delivery pipelines. You're so confident with your testing, you're so confident with your automated deployments that there's no reason to pause. Because the business trusts the fact that you know how to hide the functionality that's not ready, but's in your product behind feature switches or however you want to do that. So with continuous deployment, we turned that on for one of our teams, and we reduced the average cycle time to 21 minutes. That's from when it's ready and tested to actually in production. First day we turned it on, we had 10 deploys to production in that one day. And the team that was working on this said it was amazing. Like, they said, we can't believe we lived with slipway. We can commit our code, come back, and after a cup of coffee, we can see the results in production. And they got really good at adding extra maturity into their process. So they got good at predicting what metrics they were going to need. So they got good at predicting how is this going to look operationally. And they got really good at also maintaining their acceptance test suite. I don't know if anyone else has had acceptance tests that just stay red for a couple of days because no one can be bothered to fix it up, but they relied on it every commit, so they got really good at maintaining those. So this represented a 200-time decrease in our cycle time. So it was amazing to think we could get changes out 200 times faster than our traditional process. And it really represented more of an upward spiral. So we were reversing reversing the impact of our downward spiral, and the outlook for the future was very bright. If you've seen Puppet Lab's 2015 State of DevOps report, they've got a really interesting metric in there, and it's called deploys per developer per day. So rather than just looking at deploys per day, how productive is our organization overall, taking into account the number of developers there are. So with the Mythical Man month, it's the more developers you add, the less efficient you become. But what they're finding, if they factor high performers versus low performers, they're finding that high performers, teams like Amazon and Netflix, and they've got their leveraging Conway's law effectively in their organization. They're actually exponentially increasing the number of deploys per developer per day, versus low performers, which kind of go the other way. The more devs you have, the less likely you are to be able to release as often and as frequently. So this is kind of what this represented for us. The potential was there to really accelerate and build on how much functionality we could get out at a really fast rate.
Cool. So that's a little bit of a picture of how we went about identifying the right thing to do, and then how we incentivized it by making it easy. So we learned some stuff along the way, which we'll just quickly go through. The first thing is to get the balance right. If you've ever been stuck in a traffic jam, like the picture on the left, you gain a sudden appreciation for the value of road rules and predictability. But on the other hand, if you set up a roadblock in the middle of a highway, that's just as bad. Too many checks and balances will slow you down just as much. So you need to really optimize for speed. Keep your standards nimble and relevant. Don't stuff too much stuff in there, because it will just slow your people down. Similarly, just chip away at the iceberg. Pick the low-hanging fruit. Pick the stuff that's affecting you today, the bottlenecks, the constraints that are really hurting you right now. Don't forget about the other stuff. Encapsulate it somewhere, record it somewhere, so you don't forget about the ideas that you have, but just tackle today's problems today. Onerous requirements, well, again, slow adoption. Make it easy. If you're going to do standards, and it might not be right for everyone, it was right for us, but if you're going to do it, make it easy for people to go between standards. Every time we released a new version of standards, we made a list. In addition to the test-driven stuff that Matt was talking about earlier, we made a list in Confluence also of, okay, you need to make these 3 changes and make sure you've got the latest version of this library, sort of thing. So this is the kind of Cliff's Notes of what you need to do in order to comply with this version of the standards. And we did things like a little nav bar in Confluence so that you could easily jump between standards and see what was going on. Fourthly, the carrot, not the stick. I'm a sysadmin. This is really hard for me. I'm used to just like beating people with a stick until I do what I want. We tried that for years, and it actually doesn't work that well. What are you doing that for? You're doing it wrong. Why don't you just do it the right way? Like, what's wrong with you? But never really telling people, articulating for people how we wanted it done in a way that they could actually, do. So critically, there was no business impetus to change this. They had no idea that this was going on. IT was just slow and costly, and that's just how it was, and we'll just deal with it. But when we came up with our standards ideas and our slipway idea, we kind of tried the carrot approach. We said to people, look, you've got the potential to get releases out in a day. All you have to do, the price you have to pay, is to implement the standards. If you can't do that, that's fine. The gripway is still there. You can still release on it. In fact, it's probably better than it was before because not as many people are on it. But it's your choice. It's up to you. And we presented our ideas about this at all levels of management, right up to the then CEO of the company. And we got the whole business on board. And so business stakeholders gave their development teams time and essentially money to go ahead and spend, to pay the price of implementing the standards so that they could get onto the slipway program and start getting stuff out faster. And so the whole business was kind of enthused and on board with this idea. And it's really amazing to be a part of something like that in your organization when everyone's finally working and pushing in the same direction.
Strongly type your discussion. So I had to get a bit of a nerdy coding reference in here somewhere. When I'm working with WIG or dynamically typed languages, I kind of really miss the conversation that I have with my code. I'm instantly able to see exactly what's expected of this method or what I can return and what my clients will be able to see. It's kind of the same culturally with conversations that you have. If you're just talking about nebulous topics and you don't have good, strong labels of your conversations, it's really hard to keep that momentum going. Using terms like slipway was a unique term. It had like a nautical launching type reference. It was kind of catchy, and it only meant one thing, and it built up a life of its own. It carried its own emotion and symbolism that it had a weight of its own. And that's it's a good tip to sort of try to start climbing out of your chasm. Also, state transition tables were useful just for being able to visualize the current problems that we have and what we want to do to fix things in the future. We mentioned our glassfish deployment scripts. There were a few holes in them, and we found that when we sat down and we looked at, okay, when it's in this state and you perform this command, what happens? And for a few things, we had just some question marks or errors. Or you can imagine for a sysadmin, you've got different apps and you don't know what's going to happen for different apps. When you type a command, you just sort of see what happens. So with our lightweight apps, we were able to say, for our microservices, we were able to just sit back and say, okay, when it's in this state and we perform this action, this is what we want to do. Make sure that all the commands are idempotent, and we built a lifecycle test case as part of our compliance test suite that would just put the server in different states and perform different commands and make sure that it followed that. We learned the hard way we should use semantic versioning everywhere, also in our shared implementation libraries, which implemented a lot of the standards for our developers. If we tried to add new breaking changes that were not related to the standards and then expected teams to adopt that version of the library, they would have to adopt all those breaking changes. They should be done in a new 2.0 major version so we could adopt standards in an older minor version. Be opinionated, not arrogant. It's really important to have strong opinions and to have good, solid ideas about how we're going to go forward so you can make an agreement. But don't be a jerk. Don't say we agreed to this on the 4th of August in 2012. We have to do it. The right thing changes over time. So be opinionated, but humble enough to move on. Warranty period. So when we were adopting new versions of the standards, we realized that we couldn't predict all applications and how they would be integrated with these new changes. So we realized we needed to just set aside 2 weeks after locking down some standards for teams to go away and implement them. And in that time, we could make some changes to those standards before finally fully locking it down. And we decided that we should use a small batch size for our standards as well. So keep the innovation flowing through, keep those operational considerations coming through. One thing that we did, for example, was we say for operations, they have to, currently they have to use properties files on a disk to change features, to flip feature switches. And if there's 3 deployments, they have to do that for 3 applications. We decided let's use Zookeeper for that, and we can just do one setting and it will apply to all servers. They'll instantly listen and get that change. To push that through, what we did was we used a shared implementation library for our Zookeeper feature service, and then we made that the minimum version for a new version of the standards. So things like this, you want to roll out to all your teams for the operational considerations. We want to get these changes through quickly. So rather than batching up a lot of changes over 6 months, we'll try and get them out every 1 or 2 months. And people that are slower to adopt, maybe the application's not changing that often. They've got the same net amount of changes as the more nimble people who can catch up every couple of months. And embrace legacy. So you're writing tomorrow's legacy today. Like we have this kind of attitude about legacy code, like it's stinky, no one wants to touch it, but it was the best thing back at that time. So something we were able to do with the standards was say, well, what we're doing right now is the best, but it's not always going to be the best. But we still want to bring everyone through. So embracing that fact and incentivizing that catch-up was something we were able to do with the standards. So the building blocks that we had in place, while we didn't tackle all these chronologically going up, we did a lot of stuff in parallel, but the whole idea is once we could agree on what was the right thing, then we could layer on automation on top of that, and automated deployments, and automated testing, and compliance testing. And then we could, ultimately build this opinionated pathway that says, this is what we all believe is the right thing to do. This is how we're going to work, and you can still use the old alternative, but this is the new way, and it was a great way to be able to incentivize that adoption process. So just some quick key takeaways that we've got for later reference. DevOps for us wasn't about putting an ops person in all the dev teams. We had a very constrained ops team that were doing a lot of other stuff besides releases. So for us, it was about creating a consistent and predictable interface between dev and ops, and automating that as much as possible. So we had to, so we didn't have the overhead of a lot of that communication, a lot of that unpredictability. Should I be doing this? What should this be? How should I name these things? What are the conventions? All those questions were answered by creating consistency. And the coming together and the agreeing on things, the cultural aspects, were more important to us than the tool choices. So we used Puppet and Hirer and Zookeeper and TeamCity and a lot of tools, but they kind of came along for the ride, and the more important thing was those cultural choices. Getting that fast feedback to developers, don't negate the power of that. Speeding up those releases, getting those was what we need to do to get those batch sizes down really nice and small, lower the risk and build that trust with customers. And then, yeah, the interactive automation was helping to build that trust between our teams and climb out of that chasm. Making the releases all independent was what we needed to optimize for speed, and incentivizing that legacy catch-up to bring old code along for the ride. So we hope we've shown you that our journey was not so much about the tools, but about the coming together and agreeing what is the right thing, and then ultimately making it easy for people to adopt. Making it easy to do the right thing. Great, thanks for listening.